Hello students, how are you? I hope you all are fine and doing well. I'm Poonam Sharma, your science teacher. Welcome you all with a new chapter of carbon and its compounds. It's a chemistry chapter, an extremely important chapter according to exam point of view. So in today's class, I'll start with this carbon and its compounds. So why we study about this carbon, why this carbon is so unique. Although we have so many metals and non-metals, we know that carbon is a non-metal. But why it is so important that we are studying this carbon in so much of detail? So this carbon has some unique properties, and in this chapter we'll study about those unique properties of carbon. Carbon being non-metal, it is electronegative. As we know that non-metals are electronegative in nature and they always gain electrons. But there is some uniqueness in this carbon. I'll tell you that uniqueness later. So first of all, why this carbon is considered to be very important? Because if we look around ourselves, so in everything, in everywhere in the universe, this carbon is present in any form. It is present in plants, animals, it is present in our food, in our body, and plastic which we are using, that also contains carbon. So it means carbon is present in abundance in nature. It's not like that. Carbon occurs in nature in only in 0.03%. But in this percentage also, it is doing wonder. The property of carbon is extremely important, it's extremely unique, and it is, this carbon is very social. It is a very social element. And why I'm saying it is very social? Because it forms numerous compounds. So whenever it combines with hydrogen, oxygen, nitrogen, it forms numerous compounds like methane, ethane, carbon dioxide, carbon monoxide, carbon disulfide. So there are n number of compounds formed if this carbon combines with any other element in nature. That's why we say carbon is extremely important. It is present in our DNA, in our RNA. So it is present everywhere. Now, if in this chapter we'll study about what kind of bond this carbon make, what is the versatile nature of carbon. We are saying it is very versatile, and why it is so versatile, it is so important. So we'll study about the detail of this carbon in this chapter. Now, first of all, you need to understand there are some basic things about this unique element, which is carbon. Atomic number of carbon is 6. Its atomic number is 6. And if we write its electronic configuration, its electronic configuration is 2 and 4. And its valency is 4, and number of valence electrons is 4. So here this valency is 4 if it has 4 electrons, but no, these are valence electrons which are present in this carbon in the outermost shell, and its position in periodic table is it is present in p block, and its atomic mass is 12, and it is present in second period. So this is the position of this extremely unique element carbon in a periodic table. And these are the certain basic information which you people know about carbon. So carbon is present everywhere. It is extremely important element which is present in the nature. As I said, when carbon combines with any other substances, it forms compounds. And these compounds, certain examples of these compounds are like acetic acid. As you can see, carbon is present in acetic acid, chloroform, ethanol, methane. So these are the compounds, although many compounds are also there, but here I have taken few examples. and melting and boiling point of these compounds you should know. So as you can see, their melting and boiling point is quite low. So they form covalent compounds. And what are covalent compounds? I'll teach you later. So just remember, when carbon combine with any other elements, it forms covalent compounds. Okay, and the bond formed between them are known as covalent bonds. And these covalent bond or the covalent compounds which are formed due to the combination of carbon with another element, they have very low melting and boiling point. So these are the properties of carbon. As we are walking, so we leave our footprints behind us. So whenever we are performing any activity on daily basis, like we are producing energy, the fuels which we are using, like, and we generate energy in the form of carbon. So whatever activity we are doing on daily basis, it releases carbon. With this carbon has effect on a climate. So this impact of carbon on the climate, or the impact of carbon on the atmosphere, is known as our carbon footprints. We call it carbon footprint. So whatever carbon we are using on daily basis in any form, so that usage of carbon on daily basis, or the activities we are performing in which there is a usage of carbon. As I told you, this carbon is present in everything. Whatever things we are doing, we are generating energy, we are producing energy. We get energy from glucose, that is, this is H12O6. So that also contains carbon. So these carbon, these different forms of carbon which we are using on daily basis, that has impact on our climate, and it is known as carbon footprints. So I hope till here it is clear to you. So why this carbon is so important? So we have this carbon in our food items, in our body. We use carbon as a fuel, and carbon exists in nature in free state and in combined state as well. It exists in nature in free state and in combined state. Carbon exists in nature in different forms also. So we'll study those forms in detail later. So that's why carbon plays a vital role in our life. Now, what kind of bond is present in carbon? As I told you, carbon has atomic number 6. And if I'll write its electronic configuration, it is 2, 4. So, to obtain complete octet, it means it has a valence electrons 4. So its valency should be 4, but it is not like that. Why its valency is not 4? We are talking about this valence electrons. It has 4 valence electrons. It means if it lose 4 electron or gain 4 electron, in both the cases it attains stability. It becomes stable in nature. But this is not the scenario. If we are talking about this completion of octet, or completion of the outermost shell of carbon, so there are two possibilities. Either it gain electrons, then it becomes 8 in L shell. And if it loses 4 electrons, then also it attains inert gas configuration, which is helium. Again, it becomes stable in nature. But these both cases cannot occur in carbon. Why it happens? Let's see. If we are talking about losing of electrons, if it loses 4 electrons, so it attains helium and it becomes inert gas. But when it is losing 4 electrons, it needs tremendous amount of energy, which is impossible to create that amount of energy. So that energy is known as, because it has very low ionization energy. So that's why this carbon is not capable of losing 4 electrons. Now next is, if it gain 4 electrons, if it gain 4 electrons, if this carbon is gaining 4 electrons, then also it attain inert gas configuration, but still it is not doing it. Why? Because if this gain 4 electrons, if I'll show you the structure of this is nucleus of carbon and in which electrons are present. So here in outermost shell, 1, 2, 3, 4 electrons are present. Okay. See, it has 4 electrons, 1, 2, 3 and 4. And if it gain 4 more electrons, if it gain 4 more electrons, 1, 2, 3 and 4. So it becomes 8 electrons in its outermost shell, and the nucleus which is present in the center of this carbon, size of this carbon is extremely small, and there is a attraction between this nucleus and the electrons, because this nucleus contains positive charge due to the presence of protons and electrons has negative charge. So as a result, it has very strong this bond of this attraction between them, and we need tremendous amount of the energy to overcome this force of attraction. That's why it will not gain 4 electrons as well. So if we look at the structure of this carbon atom, which has nucleus in the center, which has positive charge on it, and 4 electrons are revolving in the outermost shell, which has 4 electrons and which has negative charge on them. So the size of this carbon atom is extremely small. As you can see, it has only 2 shells, K and L. So due to this, it needs a tremendous amount of energy. As a result, it cannot lose electrons or it cannot gain electrons. Then how it becomes stable in nature? But it exists in nature. It is a stable element. Then how it is stable in nature? Let's see here how it becomes stable. There is another option for the stability of this carbon atom, which is sharing of electrons. So it is very social, it shares its electrons with another element or with carbon. So due to this sharing of electrons, it becomes stable in nature, and which requires less amount of energy. And the bond which is formed between this carbon with the another element by the sharing of electron is known as covalent bond. So that's why it plays a vital role. Otherwise, other elements are also present in the nature which has 4 valence electrons like silicon in their outermost shell. But why they are not showing this property? Because their size is quite big, but the size of carbon is quite very small. As a result, it has very strong forces of attraction between the nucleus and the electrons. And if we look here, it has 4 electrons in its outermost shell. It has total 6 electrons. Atomic number of carbon is 6. It means it has 6 electrons. And if it has 6 electrons, and we know that number of protons is equal to number of electrons, so protons also 6. It means it has equal number of positive charge and equal number of negative charges. So number of electrons and the protons are 6, and its atomic mass is 12, because it has number of protons 6, and if you are saying atomic mass is 12, so 12 minus 6 is equal to 6. So it means it has 6 neutrons also. So it means it has 6 neutrons, 6 protons and 6 electrons. Now to become stable in nature, it shows this sharing of electrons, and the bond formed between them is known as covalent bond, which is result of the sharing of electrons. And this covalent bond is different from the ionic bond, because in ionic bond there are the transfer of electrons and ions are formed, but they have low ionization energy. That's why they'll not transfer their electrons, they'll share their electrons. They'll not gain either, neither they gain electrons nor they lose electrons. So these are the properties of this carbon atom which makes it very unique in nature, and that's why we say that carbon is extremely important. And that is the reason why we are studying carbon in detail, why we are not studying any other element. So it's a 1 mark question, why carbon does not lose electrons. Due to the very low ionization energy, it will not lose electrons. And why it will not gain electrons? Because if it gain electrons, then there is a strong forces of attraction required to overcome the bond formed between these valence electrons. So that's why it will not gain electrons. So this is 1 mark question, children. It's very important according to exam point of view. And what is the atomic mass of carbon, which is 12. So I hope till here it is clear to you why we say carbon is unique in nature. Then, as I told you, it gained 4 electrons. Then when it gain 4 electrons, it becomes C4, but it is not gaining electrons. Okay, then it becomes difficult for the nucleus with these 6 protons and to hold 10 electrons. Then if it is losing 4 electrons, it becomes C4. Okay, so it is gaining, it is not cation, it is anion. But these both cases are not possible in case of carbon, and that's why it shows the sharing of electrons, and which is known as covalent bond, in which the sharing of electron pairs takes place. That's why it forms a covalent bond. And this tendency of sharing of electrons is known as its covalency, and the bond formed between them is known as covalent bond, and the compounds which form as a result of this sharing of electrons are known as covalent compounds. These are known as covalent compounds. Now, how this covalent bond is formed in carbon atom? Let's see here. As I told you, the atomic number of carbon is 6 and its electronic configuration is 2, 4. So it requires 4 electrons to achieve this inert gas, because as we know that an element becomes stable in nature if it has a total 8 electrons in its outermost shell, or its outermost shell should be K and it has 2 electrons. So, but its outermost shell is L, in which it has merely 4 electrons, but it needs 8 electrons to be stable in nature. So that's why to become stable in nature, to attain inert gas configuration, when the outermost shell is completely filled, we call it inert gas configuration. If an element attains inert gas configuration, then only it exists in nature, it becomes stable in nature. So that's why for attaining this inert gas configuration, it forms this covalent bond. What are the reasons behind for the formation of covalent bond? Is to attain inert gas configuration in nature. So it forms covalent bond, and this carbon cannot form ionic bond because of very low ionization energy. Now, question can come in exam, define covalent bond, or how this covalent bond is formed by carbon atom. The answer or the definition for this covalent bond is the chemical bond formed by the sharing of 2 valence electrons between 2 atoms is called covalent bond. What type of covalent bonds we have? See, we have different type of covalent bonds, which is single, double and triple. If there is a single sharing of single pair of electron takes place, we say that it is a single covalent bond. If 2 pair of electrons are sharing with each other, we said it is double covalent bond. But if we are saying 3 pair of electrons are shared, we say it is a triple covalent bond. So when only one the sharing of electron takes place, it is single, which is represented by this single line, and double covalent bond, if 2 pair of electrons are shared, so it represents by double lines, and if 3 electrons are shared, it represents by triple lines. So these are different types of covalent bond. Okay, Now there are certain examples in which we can see these different types of covalent bonds. If we'll take an example of fluorine, chlorine and hydrogen, there is only sharing of single electron takes place. We'll study in detail. And if we talk about double covalent bond, oxygen and carbon dioxide. Carbon dioxide is a compound and it is an element. So in both the cases, we can see the double sharing of electrons takes place. That's why it's a double covalent bond. Now, third is nitrogen is an example of triple covalent bond. As you can see in this diagram, if you look here, bond which is formed between hydrogen and hydrogen, it is a single bond. And if we look at this carbon dioxide, as you can see, these are represented by double lines. It has double covalent bond. And if we take an example of nitrogen, it has triple covalent bond. Now, how these covalent bonds are formed? So let's see the formation of these different kind of covalent bonds. And before that, you should know about electron dot structure, which is given by Lewis. Electron dot structure, it means the outermost valence electrons are represented by dots. If we look at the example of hydrogen, atomic number is 1 and its electronic configuration is 1. So it has one electron in its outermost shell, which is represented by one single dot. And if we look at the example of calcium, 2882, this is the electronic configuration of calcium and it has 2 electrons in its outermost shell. So as you can see, 2 electrons are there which are represented by 2 dots. Similarly, in the case of aluminium also, it has 3 electrons in its outermost shell, which is represented by 3 dots. And if we look at this carbon, which is a unique element, its 4 valence electrons are represented by these 4 dots. And if we talk about nitrogen, 2, 7. So 1, 2, 3, 4, 5. 2 and 5. Its electronic configuration is 2, 5. It has 5 electrons in its outermost shell because its atomic number is 7. And if we look at the example of oxygen, it has 2 to 4, 5 and 6. So it has 6 electrons and its atomic number is 8. So we'll write its electronic configuration like this, which is 2, 6. So it has 6 electrons in its valence electron, 6 in its outermost shell, and these 6 electrons are represented by these dots. Now look at the example of chlorine. So it has 7 electrons in its outermost shell, or we can say that valence electrons of chlorine are 7. So they are represented by 7 dots. And if you look at the example of argon, which is an inert gas, it has 8 electrons in its outermost shell. These 8 electrons are represented by these 8 dots. Now look here, carbon dioxide. We'll study about this formation of compounds with the help of covalent bond later, but just look at this carbon dioxide, which is a combination of CO2. So here oxygen 2 to 4 and 2 is shared by this carbon. Here again 2 to 4 and these 2 are shared by this carbon. That's why it becomes stable in nature. So this is how they are forming covalent bond. Now if we talk about dihydrogen monoxide, or it's a formula of water, as you can see, it has 1 electron, which shows the pairing. And this oxygen, although it has 6, 2 to 4 and 1 electron is shared with these hydrogen atoms, which results in the formation of water. So this representation of valence electrons or the electrons present in outermost shell by dots is known as electron dot structure, which is given by Lewis, or Lewis structure. We call it Lewis structure. Now how this formation of hydrogen molecule takes place with the help of covalent bond. As we know that the atomic number of hydrogen is 1. So if I'll write the electronic configuration of hydrogen, it is 1. And how can we represent by the electron dot structure? Now you can see why this electron dot structure is important in representing the covalent bond. So if I'll write this hydrogen, so hydrogen does not exist in nature in a free state. So to be stable in nature, to attain inert gas configuration, it combines with any other hydrogen atom to become stable. Hydrogen has only one electron in its outermost shell, and this hydrogen also has one electron in its outermost shell. Now, if these one share its one electron with this one, I'll write like this. So they have one electrons. It means these one electrons share with each other. They'll show sharing. And how can you represent it? See, it has one electron plus it has one electron. Now, if they both share their one electron with each other, that shows the sharing. It means this electron of hydrogen and this electron of hydrogen, they are sharing with each other. Now it has two and it also has two. It becomes stable in nature, and the bond formed between them is known as covalent bond. This is known as covalent bond. This is single covalent bond. As you can see, only single sharing of electrons takes place. So that's why it has single covalent bond. So how this hydrogen molecules exist in nature, or it attains inert gas configuration, or it becomes stable in nature. Now next is formation of CH4 molecule. CH4 is methane. And if we see the configuration of CH4, as we know that carbon atomic number is 6 and hydrogen atomic number is 1. And if we'll write their configuration, it is like this. It has K and L and it is K. So it has 4 electrons in its outermost shell and it has 1 electron in its outermost shell. So to become stable in nature, carbon can combine with one or more elements. So when it is combining or sharing its 4 electrons, as I told you, carbon cannot lose electrons or it cannot gain electrons, but it can share its electrons. So here it has 4 electrons in its valence shell. So if we look here, carbon, it has 4 electrons, 1, 2, 3 and 4. This is according to the electron dot structure. So we are representing valence electrons by dot, and this kind of structure is known as electron dot structure. So here we need 4 hydrogen atoms, and all these 4 hydrogen atoms has one electrons in its outermost shell. As you can see here, they all have 1 electrons in their outermost shell. So this shows pairing of electrons. As you can see, it shows this pairing, and if we look here, this one and this one finally. So now let's see here, this carbon share its 1 electron with this hydrogen, and here it is sharing 1 electron with this hydrogen, and here also it is sharing 1 electron with this hydrogen, and here it is sharing 1 electron with this hydrogen. So in this manner it is sharing one electron with each hydrogen atom, and because sharing of 1 electron at a time takes place, so it results in the formation of single bond, because here only sharing of 1 electron takes place. So it forms single bond. This is the example of single covalent bond, or we'll write this formula like this. This is how you will represent this methane. Now next is formation of carbon dioxide molecule. As we know that when carbon combines with oxygen, it forms carbon dioxide. Let's look here how this carbon dioxide molecule formed in nature. Carbon, its electronic configuration is 2,4, and oxygen, its electronic configuration is 2,6. And if we'll write their electron dot structure. First, as I told you, it needs two electrons to get inert gas configuration and to be stable in nature. So what it will do, it will combine with two oxygen molecules in nature. So here I'll write one oxygen and here I'll write one oxygen. So each oxygen has 6 electrons in its outermost shell, or we can say each oxygen has 6 valence electrons. So we'll represent these valence electrons by these dots according to electron dot structure. And this carbon has 4 valence electrons. So I'll write these 4 electrons like this because it will share 2 electrons with each of the oxygen. If it will share these 2 electrons with this, it attains inert gas 6n28 and 6n28. So this oxygen becomes stable, this oxygen becomes stable, and this carbon also becomes stable in nature. So in this manner, if they are sharing their electrons, they all become stable in nature, which results in the formation of carbon dioxide in nature. And here you can see there are sharing of 2 electrons at a time takes place. Here it is sharing 2 electrons. Here also it is sharing 2 electrons. So it means it forms double bond. And this type of double bond is known as double covalent bond. So this is how you will represent formation of carbon dioxide molecule by electron dot structure, or you can show it like this. Okay, then you can show this oxygen, stability of oxygen, and this is how this is stable, as you can see here. So I hope this is clear to you how this covalent bond formation takes place in carbon. As you can see that carbon can combine with elements, and if it combines with any other element in the nature, it results in the formation of compounds, and this type of sharing is known as covalent bonding, and the bond which is formed is known as covalent bond, and this compound which is formed as a result of this sharing of electron is known as covalent compounds. Now next example is H2S. How this covalent bond formed in H2S. Here although carbon is not involved, but this covalent bond takes place in other elements as well. Here also this sulfur, if it combines with hydrogen, as you can see the atomic number of sulfur is 16286. So it needs 2 electrons to get an inert gas configuration. So we'll represent this sulfur by this 6, 1, 2, 3, 4, 5, 6. But we need, it is combining with 2 hydrogen. So we'll write like this 1, 2, 3, 4, 5 and 6. And hydrogen has 1 and this hydrogen has 1. Okay, then 6, as you can see here, H2. So here it needs 2 electrons. It will take one from here, one from here. So it results in the formation of this kind of bond. Okay, as you can see, single transfer of electron takes place, which results in the formation of H2S. This is also a covalent compound. Now, what kind of question can come in exam? Question can come, name a molecule that has triple bond, and answer is nitrogen. How? Let's see here. Nitrogen. Atomic number of nitrogen is 7 and its electronic configuration is 2, 5. So we'll represent, it needs 3 electrons to make its octet complete. I'll represent it like this 1, 2, 3, 4, 5. In nitrogen 1, 2, 3, 4, 5. So if 2 nitrogen combines together, they share their electrons, and as you can see 3, 4, 5, 6, 7, 8. Now it becomes stable. and it also becomes stable. And there are sharing of 3 electrons takes place, so that's why we'll write 3, and it is an example of triple bond. Draw the electron dot notation or electron dot structure of oxygen. So we'll write like this. As you can see, 2 to 4 to 6, 2 to 4 and to 6. There is sharing of 2 electrons takes place, or double bond is formed. And name the hardest substance known, that is diamond, which is an allotrope of carbon. We'll study about in detail later. Carbon exists in nature in 3 forms basically: diamond, graphite. It exists in nature in free state in form of coal, and Buckminster fullerenes. Okay, so these are the different allotropes: diamond, graphite and Buckminster fullerenes. These are the 3 allotropes of carbon. And what are allotropes? When an element exists in nature in more than 2 forms, we say that these are the allotropes, and the process is known as allotrope. So I hope till here it is clear to everyone how these electron dot structures are formed, and why this carbon considered to be unique in nature, although many metals and non-metals exist in nature. But why this is so important? There are certain unique properties of carbon which makes it very important in the nature, because it has tendency to combine with any other substances and to form numerous compounds. So till here I'll wind up my class, and thank you everyone. So please go through it and revise whatever I taught you in the class. The next class I'll continue with the same chapter. Till then, bye and take care.